Welcome to the second video in the, I believe, 3 videos that I'm going to shoot for section 7.3. Now, we did the first 6 questions, and the first 6 questions weren't all that bad because all the denominators had the same denominator. And so that was relatively easy to perform those calculations. Now, I'm going to start off this video with chapter 7, with question 7, and they're asking you, the following expressions represent denominators of rational expressions. Okay, find their lowest common denominator. Well, basically what they're saying is pretend we had 1 over 3x plus 5. Okay, as an expression, plus, and you want to add that to 4 over 2x plus 5. Okay, you can't do this problem right now because the denominators aren't the same at all. So in order to do this type of problem, you got to make these denominators the same. And then you're going to need to rewrite the fractions with the different denominators. Well, first off, how do we find the expression that would make this denominator and this denominator the same? Well, here's what you're going to do. I have this little slide that I will have in the Blackboard section. You'll be able to look at this and say, well, how do you find the least common multiple? Or it's also called the least common denominator. Okay, so what you're going to do is first factor the expressions. That's got to be the first thing that you do with the denominators, is factor the denominators. Okay, we didn't have to do that in the first 6 questions because the denominators looked the same, were exactly the same, and you didn't have to do this process. And then after you factor the expressions, the least common denominator must include all the factors you see, highest power. And I should also say all the factors you see listed once, highest power. Now pretend I have denominators 25 and 30. Okay? What do I mean by that? Well, I could factor 25 to be 5 times 5. You remember that prime factorization that you did way back in basic math? You can break down any number in as a series of prime numbers. So 25 is equal to 5 times 5, and 30 happens to be equal to 2 times 3 times 5. Okay, I don't think there's any argument with that. Now, we factored the expressions. In this case, we factored the numbers. The lowest common denominator must include all the factors you see. I see a 2. So therefore, the least common multiple, least common denominator, has to have a 2. I see a 3. It has to have a 3. I see a 5. I list it once. I see a 5, but you take the highest power 5 you see. 5 squared. There it is. So 2 times 3 is 6. Times 25 is 150. That's the lowest common multiple. I'm going to post this in your Blackboard unit. Let's minimize that. Let me save this. Okay, let's just save right there. Minimize that. Okay, so if the expressions represent denominators, what's the lowest common denominator? Well, you have to have every factor you see listed once. I see a 3. Least common denominator, LCD, or LCM, it doesn't matter, has to have a 3 because I see it listed as a factor. Okay? It also, let me just do the simple factors. I know I see at x plus 5, but I don't want to put that next because it just doesn't look right. Is there another number that I can put there? Yeah, 2 times 2. There's another factor right there. Okay? And then I see an x plus 5. Just because it happens twice doesn't mean you list it twice. Okay, what you're going to do is you're going to say, well, I see a factor of x plus 5 bundle, and the highest power x plus 5 bundle I see is got a power of 1. So that's it. That's the biggest one. So what you're going to do is you're going to say 6. 3 times 2 is 6. And I would probably just leave this alone like this. Make it look like, just leave the factors there. Don't have to multiply through. That's the lowest common denominator. 6 parentheses x plus 5, close parentheses, check your answer. There you go. That's it. I'm not lying to you. What's the next one? Find the following expressions represent spelled wrong. Okay, represent denominators of rational expressions. Find the lowest common denominator. The lowest common denominator has to be factored. All these denominators have to be factored. Well, you can't factor t. T is what it is. That's a bundle. There's not much you can do there. And t minus 10 is a bundle. So what? Okay, so they're all basically factors in itself. You always have to list every factor you see listed once highest power. Well, I see a t. And then I see a t plus 10. And then I see a t minus, let's close that parenthesis out. And then I see a t minus 10. And that product, don't have to actually do the math out. That's the lowest common denominator of all the factors you see. Great, 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 great. Now, what's if the denominators of the expressions are x squared minus 64 and this, what's the lowest common denominator? Well, according to my little document here, you have to first factor the expressions. Okay, let's factor the expressions. And let's start off nice and fresh. Don't save. File, new. Okay, now we got a nice fresh canvas. Okay, so x squared minus 64 is equal to, well, I'm going to say this, x plus 8, x minus 8. Because it's a difference of 2 squares. These are my factors. And then the bottom guy, this guy right over here, x squared minus 7x minus 8. Well, I have to factor that. And I think at this point, let me just give you the answer because you know how to do this. X minus 8, x plus 1. Okay, that'll certainly multiply out. So now, the lowest common denominator has to have every factor you see. I see listed once, highest power. So I see an x plus 8. I don't see any higher power x plus 8. I see an x minus 8. I don't care that it occurs twice. X minus 8, and that happens to be the highest power x minus 8 that you see. And then this is x plus 1 is another one. That's all you do. You just scan your factors and list them as one big multiplication. Check your answer. Fantastic. Now write the following expressions in terms of their LCD. So basically what they're saying with this problem here, let's go backwards a little bit and show you. Remember how you did fractions that didn't have variables? Let's just say I did 7 over 30, okay, plus 4 over 25. Okay, right now you can't do this problem because the denominators aren't the same. So what's the lowest common denominator? Well, from the slide, all right, I use that as an example. 25 is 5 squared, 30 is 2 times 3 times 5. So what I'm going to do is say, well, this, right below, I'm going to put my 5 squared here. Just, whoa, wrong place. Wrong place. Edit, undo. Edit, undo. That's the wrong spot. Because, well, it's another one. Edit, undo. And then I'm going to put the 5 squared here. That's where the 25 is. And this is 2 times 3 times 5. Okay, so let me push this up a little bit. Bring this down. Well, here's what's the common denominator. The common denominator is got to have a 2. It's got to have a 3. It's got to have a 5, but you take the highest power 5 you see. Okay, now let's go over here because I didn't give myself enough space here. This is going to be 150 as a denominator plus 150 here as well. So that's the common denominator, lowest common denominator. Now what we want to do next is adjust the numerators. We got basically that's what they're asking for in this problem. Express these expressions in terms of the lowest common denominator. Well, in this case, the lowest common denominator of these fractions are supposed to be 150. You have to adjust the numerators. You just can't call them 7 and 4 because that's a different fraction. See, 30 goes into 150 5 times. In order for that 30 to become 150, I got to multiply that by 5. And whatever you do on the top, bottom, you got to do up top. So 7 times 5 is 35. Okay, now that's the same fraction as this. And likewise, this 25 has to be multiplied by 6 to get 150. You got to multiply the top by 6, which is 24. Now you could do the problem. 150 is the end answer, and this looks like it'd be 99. No, what am I, not 99? This would be 59. 59 over 150 for this contrived problem. So, think about the technique I just showed you here. Let's see if we can apply that technique there. So here's what we're going to do. File, let's close this out. Don't save it. File, new. And we're going to come over here and say, well, this is going to be, let's write these fractions down. 2, 3y. They don't want us to do the addition. They don't want to do any subtraction. They want us to take these fractions and prepare them to be added or subtracted. Okay, so in other words, down here, I'm going to rewrite the fractions. Let's see, the common denominator looks like it has to be 3, has to have a 3, and it has to have a 5. Why don't we call that 15? Okay, maybe you don't have to break these numbers down into prime numbers, but the lowest common denominator is the smallest number that 3 divides into and 5 divides into evenly, and that's 15. Okay, that would be 15. Or you can just simply say 3, 5, and then in the end multiply out. You also have to have a y, because that's another factor I see. But what's the highest power y term that you see? I see a square y. That's the one you use right there. Okay, that's done. That's done. Now we got to adjust the numerators to reflect the common denominator. Well, this 3 has to become 15. I got to multiply by 5. This y has to become y squared. I got to multiply by y. Multiply those two, you get this on the bottom. Whatever you do on the bottom, you have to do up top. And that's 10y. Okay. This fraction has to look like this fraction denominator. So we're already good with the y squares. Y squared is good, but that 5 has to become 15. That means I got to multiply the bottom by 3. I got to multiply the top by 3. That's 18. And that's all they want us to do. Do we see something that looks like that? Let's see. Let's come over here. Do we see something that looks like that? Well, what does it look like? Let's push this over here. I'm going with, I'm looking at C. I'm looking at C. Yeah, C. Don't overthink it. Right there. Those are the two fractions I came up with. Check your answer. Fantastic work. Okay. Same thing on this one. Let's go ahead and say file. Let's close it. Don't save it. Let's say file, new. You know what? I'm going to give it a little bit more height. Maybe 1,000. Okay. Let's do that. That might be too much height. But that's all right. That might be too much. And, okay, write these fractions out. 7 over 3a squared. A minus 1 over 4ab. Now, here's what this says. Here's what we have to do. Factor the expressions, and then the least common denominator must include all the factors you see listed once highest power. Okay. These are already factored. There's no pluses and minus signs. There's nothing to factor here. These are all factors, all involved in multiplication. That's good. So, what do we do now? We rewrite the fraction. We find the lowest common denominator. And generally what I do is I say, well, what's the lowest common denominator of 3 and 4? Okay. 12. 12. 3 goes into 12, 4 goes into 12. That's the smallest number. I also have to have an A. I list every factor you see. Put it both places. But what's the highest power A you see? I see the square. And do you see any other factors? Yeah, I see a B. You've got to put B's there. List them once. Okay, now we've got to adjust this these fractions. We have to adjust. We made this denominator look like this. We have to adjust the numerators. So the idea here is what we have to multiply the bottom original denominator with to get the common. 3 has to become 12. I got to multiply by 4. I'm good with the a squares. I don't adjust the a squares, but there's a b missing here, but not in the common denominator. I got to multiply by b. That's a b. So wouldn't you say if we multiplied those two out, we would get 12a squared b? I think so. Whatever you do on the bottom, you do up top. See? And so we're going to say 28b. Now remember, this is a bundle. That's a bundle. Okay, look at the denominators. Compare the denominators. 4 has to become 12. I got to multiply by 3. A has to become a squared. I got to multiply by a. We're good with the b's. Whatever you do on the bottom, you do up top. And so, what I'm going to have here is 3a, a minus 1, and I think that's all they want us to do with the problem. That's all they want us to do. So what I'm going to do is move this over so we can see the end answer. And I'm going to say, well, there's no multiple choice here, but what we're going to say is the top here is 28b over 12a squared. Bring it down to b. And this guy over here is same denominator, so I'll get that done first. And you don't even need to multiply that out. Leave that alone. Just say 3a, a minus 1. They look totally different. Okay? You know, the rewritten fractions look totally different from what we started with, but these are the fractions. See, now these fractions can be added if that's what you wanted to do. Those can be added. I'm going to have to show you how to do that. So a little bit at a time. Little bit at a time. So, you know what? I'm going to let you do this one. I'm going to let you, it's the same thing as what I just did. Same thing as what I just did. What did I just do? How come I can't go? Wait a second. What did I just do? 11. Oh, I don't know what happened there. I think I said do another one of those problems. Okay, number 12. Don't worry about it. 12. Don't save it. Let's do a new. Let's not do 1,000. Let's do 800. 800. Okay, that's a better size. Write these things as a, in terms of LCD. Well, if I were trying to add or subtract these fractions, I can't. So what I need to do is say I got to factor the denominators. So here's a denominator. I'm going to factor it. 3 over n plus 1. And down here is n squared plus 1 minus 1, n squared minus 1. And it's a difference of 2 squares. N plus 1, n minus 1. So here's what we're going to do. What we're going to do is say, well, 4n is 3n plus 1. Okay, so this is what I did. I factored that to make it look like this. And then I said 5n over n plus 1 n minus 1. Okay, now that we've got factored denominators, we can write the common denominator. So what I'm going to do is rewrite the fractions twice. The common denominator has to have every factor you see listed once, so it has to have a 3. It has to have an n plus 1. I don't care. I see n plus 1s everywhere, but you only listed once. And the highest power n plus 1 is what you see here, 1. That's the highest power. Okay. And then we have to have an n minus 1, because I see it listed here, n minus 1. So let's write this out again, because all these fractions have to share that same denominator. Now here's what we got to do. Compare the original denominator with the common denominator. What's missing? Let's see. I have the 3, I have the n plus 1, but I have to I have to multiply an additional n minus 1. So I have to multiply the bottom by n minus 1. I got to multiply the top by n minus 1 for that fraction. But I'm not going to do the actual multiplication through. Leave that alone. You don't need to. Now this one's a little bit easier because I already got the n plus 1. I already got the n minus 1 in those fractions. What's missing is the 3. I got to multiply the bottom by 3. I got to multiply the top by 3. So 3 times 5 is 15. And I'm going to enter these two expressions into these boxes and see what we get. Fraction. 4n, parentheses, n minus 1, close the parentheses. And this guy here is going to be 3n plus 1. You don't have to multiply through, thank goodness. And then over here, I'm going to say fraction, 15n, same denominator, 3n plus 1, n minus 1. And I'm not going to overthink this. I gave it enough thought. Check this. Nice work. Fantastic. Okay, now we're going to start doing some of these problems here. Okay, now we're going to start doing adding and subtracting. We'll do about four of them, and we'll stop the video and give you a little chunk of additional knowledge in order to do the next maybe 10 questions here. So we're going to stop probably in problem number 16. File, new. Okay, so what do we do here? Well, the first thing you're going to do is copy the problem. Plus 7 over 5x. Okay? All right, now we got the tools to do this problem. we can't add those. They're not the same denominator. I need to find a common denominator. With these denominators are already factored, so we have to list every factor you see listed once, highest power. 5, I gotta have a 5, and we have to have an x. Don't say x squared because you see it twice. That's not the point. I see an x, you listed once, that's the highest power x you see. Now we have to adjust our fractions. Okay, so I gotta multiply the bottom of this fraction by 5. To get the 5x, I got to multiply the top by 5 to get 30. And look at this. This didn't really change. From going from here to the same denominator, nothing changed. So now we can just add the tops to get 37 over 5x. That's a really ugly fraction. Let's put it in. It'll look better when I enter it here. 37 over 5x. Check your answer. Fantastic. Fantastic. Okay, each problem gets a little bit more difficult as we perform it, but it's not going to be so difficult that would require a lot of space to do this one here. So I'm going to say copy the problem. Minus 7 over 2p squared. Okay, I got to rewrite this. The denominators aren't the same. So I'm going to rewrite my fractions underneath. What's the common denominator of 4 and 2? Don't say 2. 2 is a factor. 2 is not the lowest common denominator because 4 can't divide into 2. 4 is the lowest common denominator. 4 divides into 4. 2 divides into 4. That's the lowest common denominator. And I see a p. I'll list a p there. But what's the highest power p you see? I see a square, and that's what I'm going to use, the highest power. Okay, start from here. 4s are, we're good with the 4s. We start with 4, we end up with 4. That's good. We don't have to adjust it. But p has to become p squared, which means I got to multiply the bottom by p. Whatever you do on the bottom, you have to do up top to adjust it. That's 5p. This second fraction starts with p squared, ends with p squared. We don't have to adjust it, but 2 has to become 4, which means I got to multiply the bottom by 2. I got to multiply the top by 2, which is 14. Now we can look at the numerators. 5p minus 14. That's your numerator. 5p minus 14 divided by this common 4p squared. So let's see what happens here. I'm going to put that in there. 5p minus 14 divided by 4p squared. Check your answer. Well done. Well done. That's it. Huh? Looks more complicated than what we started with, but what we started with had 2 fractions, and now we have 1 fraction, and I guess you need that complexity if you want to represent the value in 1 fraction. So again, we do more and more of these, you'll get the knack of this. Okay, I'm going to leave this one for you. That's not a hard problem to do based on what we just did. So I'll let you give you that one. I'm going to do this one. So I'm going to go ahead a couple ahead. I'm going to not stop at 60, maybe stop at 20 or something. Don't save, file, new. Okay, check this out. Okay, here's our fractions. This is z minus 7 plus 5 z plus 7. Now this is a bundle, and that's a bundle. Factor your denominators. They're not the same denominator, so you can't do this multiplication or just addition. You can't do that. So I got to find the common denominator. And it's very simple. The common denominator has to have every factor you see. I see a z minus 7. I'll list it over here too. and I see a z plus 7. There's your common denominator. Now the next thing I'm going to do is I'm going to bring down the numerators, bring this numerator down, and ask myself, what do I multiply this numerator by to get the common denominator? What's missing up here is a z plus 7. So you have to multiply the bottom by z plus 7 to get the common denominator. So I got to multiply the top by z plus 7. Now we start off with z plus 7. We end up with this complicated lowest common denominator. What's the missing factor? I have to multiply the bottom by z minus 7. See, going from here to here, I have to multiply the bottom by z minus 7. You've got to multiply the top by z minus 7. Okay, the worst is over. Believe it or not, the worst is over. We can now add the numerators, but to add the numerators, you've got to make sure you multiply these out and multiply these out. You've got to do your multiplications first before you can do any additions. So what I'm going to do is say, well, here's what I'm going to do. Z plus 5z plus 49 over, blah, that's okay. I don't care about the denominator. The denominator did its job. Don't need to waste time entering that. Same thing with blah, blah, blah here too. But I will say 5z minus, wait a second, this is not 49. This is 5 times 7. Ooh, see, I got to clear this out. That's 5 times 7. I don't know where 49 came from. Okay, I don't know where that came from. That's going to be 5 times 7 is 35. Okay, that's good. Now this is going to be 35 here as well. Now you could add these tops nicely. You have nice nice variable terms. 5z plus 5z is 10z. 35 plus a negative 35, no more. Divided by. Well, I can't say blah, blah, blah here. I got to say this common denominator, z minus 7, z plus 7. And I got to believe that's right. I got to believe that's right. So let's come over here, 10z. And on the bottom we have, you don't have to multiply this out. Just say z minus 7, z plus 7. That's exactly what I have in my paper here. Let's just hit OK. Great. Nice work. And let's see what the next guy here is. Okay, I'll do that one. I will do that one. 18 looks like an interesting one. 19. And I'll stop at 19. I'll stop at 19. Okay, that's what I'll do. Just 3 more problems in this video. That's it. File, new. And I'm going to stay over here. Put this over there and say P plus 4. And that's a bundle. That is a bundle. Divided by 3 minus 4p plus 3 bundle. Divided by 7. Well, this is not too bad. 3 and 7. There's no variables, 3 and 7. So what's the common denominator of 3 and 7? 21. Okay, I'm going to bring down my numerators because they're going to be multiplied by something. Okay, so I'm going to bring those down. They have to be adjusted by some multiplier. Now, what do I multiply this top by? Well, 3 has to become 21. I got to multiply by 7. Got to multiply the top by 7. Okay, done with that one. 7 has to become 21. I got to multiply the bottom by 3. I got to multiply the top by 3. See, we're saying the same thing over and over again. Now, before you could subtract, you gotta multiply through here. You got to expose these terms so that they can be combined. This is going to be 7p plus 28 over 21 minus 12p plus 9 over 21. Now the denominators are the same, but we got to be careful here because we subtract everything to the left. So this is not just simply going to be minus 12p plus 9. It's going to be another step. 7p, whatever is on the left side of that minus sign just stays the same. Minus 12p minus 9 over 21. Now what I'm going to do is I'm going to combine my like terms on the top. I'm going to put the answer over here. Combine my like terms on the top. 7p minus 12p is going to be a fraction. And I might as well put the 21, the easy thing, on the bottom. 7p minus 12p is minus 5p. 28 minus 9 is plus 19. Okay, 19, and I'm going to check my answer and see a green box. Okay, and I'm going to see a green box right there. Two more, hang in there, just two more. Let's see what this one here looks like. I'm going to have to get some new canvas here. And what I'm going to do is move this over and say, well, here. 4a plus 1. You might as well make a bundle out of that. Over 12a. Minus a squared. Minus 6, which is a bundle. Make a better look at 6. Okay. 3a squared. Step 1. Are the denominators the same? Of course not. Okay? You got to make them the same. This isn't too bad, though. Because the common denominator, just look at the numbers. Don't worry about the a's. Look at the numbers. Common denominator has to be 12. The lowest common denominator of the numbers has to be 12. I also have to have an a. And the highest power a term I see is the square. And there's your common denominator. Next step is to bring down the numerators because they have to be adjusted. That's the bundle I brought down. And over here is a squared minus 6 that needs to be adjusted. Now what do I do? What do I mean by adjusting? I start off with 12a, I end up with 12a squared. I got to multiply the bottom by a, I got to multiply the top by a. That's done on that side. I'm good with the, so in this fraction, I start off with a squared, I end up with a squared, good with a squared, but 3 has to become 12. I got to multiply the bottom by 4, got to multiply the top by 4. Next thing is before we can subtract, we've got to multiply. We have to expose these terms so that they can be combined later. We have to multiply. See, this is multiplication. That has to be done first before you subtract. So this is 4a squared. I'm just doing a distribution. Plus a. This times this times that. And this is going to be 4a squared. Minus 4 times 6 is 24. And blah, blah, blah. I don't want to even write the 12a squared down. We're subtracting. So we got to be careful when we subtract. Keep the first terms to the left. 4a squared plus a. Those stay the same. But what I do here is I say minus 4a squared. Minus a minus is plus 24. That's a squared. Okay. Over blah, blah, blah. And the last thing that we're going to do is combine our like terms, which I think I'm going to do right over here. I'm going to put those right over here, right in the end answer. Okay? The end answer has to have a denominator of 12a squared. And let's see. 4a squared minus a squared is 0. 0a squared. They cancel out. Goodbye a squares. I'm left with an a plus 24, and that's what goes up top. A plus 24. Check your answer. Fantastic. Fantastic. It's the same answer. Now, this guy here, and I'm going to leave you, this is the last thing that we're going to do. This is the last thing that we're going to do. This guy here is an oddball. It's one of these. In math, there's always some deviation from the general rule of anything. And this is one of the strange oddball cases. And let me just show you what I'm talking about here. A squared over a. These are the same a's. Those are the same a's, and that's a bundle. Minus 3 over 1 minus a. That's a bundle too. Now, these two factors look different, but they're related. Okay? The problem with this one is these are related. These are opposites, right? A, negative 1, 1. Those are opposites. And so when you have factors that are opposites, you have to handle them a little bit differently than what we talked about before. And here's how you're going to handle them. And it's not that hard a problem. Okay? This fraction here doesn't look right. It's got the 1 in front. This one looks good. A is in front. That looks good. I can make this ugly fraction, the one that doesn't look good, look better by simply, what's the magic number that pops in your head when you hear the word opposite? Minus 1. Minus 1 is the magic number. I'm going to take the ugly fraction and multiply that ugly fraction top and bottom by minus 1. And you're going to say, well, that doesn't change the fraction. It just means that it's going to change how the fraction looks. So minus 1 times negative a. Negative 1 times negative a is a. Negative 1 times 1 is negative 1. Look at this. See, the original fraction is a minus 1, a squared. I didn't change the pretty fraction. That one's okay. But by multiplying the bottom by minus 1, because we noted that the denominators or these factors were opposites, the one that looks ugly, I'm going to multiply that by minus 1 so that when I do the multiplication, negative 1 times negative a is a, negative 1 times 1 is negative 1, and it just so happens that they look the same. But up top, it's negative 3. And so what I'm going to do now is subtract negative 3, a squared, minus a minus 3 is plus 3. When you subtract, a negative number is positive, over the same denominator. There's your answer. We're not going to see too many negative problems or opposite problems, but you might see one problem that looks like this. Certainly on homework 19, homework question 19. But just understand how I'm doing that. A squared plus 3, and we have an a minus 1. Check your answer. Well done. We'll stop right there. This was getting a little bit long. So the next video, we're going to pick up where we left off, problem 20, and we'll do 6 problems, and hopefully this will all click in. All right. Take care. Bye.